Hi, this is Sue McBride, your statistics math professor, and I'm going to be going over Chapter 1, Section 1.1 on this particular PowerPoint. As this is the first one where you're actually learning material, what I usually do is quickly go through the vocabulary with you, make extra little comments like you might not have found in the book, or sometimes it just helps people to hear information. Then I will look at the examples on the PowerPoint, and I have some additional examples on the last PowerPoint slide from the text. So if you want to fast forward to that, you can click through as quickly or as slowly as you want to. All right, so let's get started. So in the very beginning, we need to set up the vocabulary. What is statistics and what are statistics? It's both a singular and a plural. So getting these basic definitions down at the beginning is critical to understanding what's going to be happening through the semester. So we have two definitions of statistics. It is a science, which I mentioned in the top of the notes that you'll be filling out, in that it takes vocabulary, a little bit of math, and a lot of interpreting. So it is a science of collecting, organizing, and interpreting data. But then the statistics, in a different sense, are the actual data themselves. So one's a singular, one's a plural. And it's the number or pieces of other information that describe or summarize the characteristics you're looking at. So statistics is a science, and it's also used to say that it is the actual data. Data is statistics. How does it work? What is the goal of research? All right, so whenever you're going to research, you're going to be looking at what's called a population. It can be a set of people or things. So population doesn't necessarily mean people. It can mean potatoes you're studying, or plants, or organisms. Doesn't matter. It's just the complete set. So keyword here is, oh, there's a typo on that. It says complete set of people or things being studied. A population parameter, therefore, are the specific characteristics of that population. So if you were looking for the mean of the potatoes, then the population parameter would be the mean, and the population itself is the potatoes. So notice P goes with P, population goes with parameter, because we're going to talk about something else in a minute that will help you to remember. Population goes with parameters. So in these situations, what are the population and the population parameters? So you're working for Farmers Insurance. You've been asked to determine the average, usually the mean amount paid to accident victims in cars without side impact airbags. So your population consists of the people who have received the insurance payments. The information of interest is the mean, so that's the population parameter. It is a characteristic of the population, where the population is the people who received insurance payments. Notice how precise that is. People, not just people in America or people who were driving cars. It was people who received insurance payments for accidents in cars. Very specific. So here we're looking at McDonald's. I knew this one was coming, talking about the potatoes. So here we want to determine the weight of potatoes delivered. So my population is those potatoes that are coming in. The parameter would be their weights. So population is the potatoes that got delivered. Relevant information is the weight. Here we have a business reporter covering Genentech Corp, and you're investigating where their new treatment is effective against childhood leukemia. So here my population again is going to be very specific. It's going to be children with leukemia. I'm not worried about adults with leukemia. I'm not worried about children with other diseases. My population very specifically will be children with leukemia. Then my population parameter we're interested in is, of those children, what percent recover without the new treatment. So one thing describes what we're studying, and the other describes a characteristic of it. That's the parameter. All right, so what actually gets studied? So when we're doing our study, we take a sample or a subset of that population from which the data are obtained. Those actual measurements or observations are called the raw data. So when I ask you to tell me what the raw data is, it's those actual measurements. So a sample statistic then are the characteristics of that sample. So in other words, if we're back to our potato example, we take a sample of potatoes, we measure their weights, that would be the raw data, and then we could take the mean of that raw data, that would be the sample statistic. So we take a sample of a certain size, we measure what it is we're interested in, and then we put that into numerical form usually, and that's your sample statistic. So here we've got the civilian labor force, and we're interested in seeing who's employed or seeking employment. So read that slide a little bit, and then I'll pause a minute while you read it. Okay, so I like to take a look at this. Now, if I was in the classroom, I'd be underlining things here. For the population, notice we're interested in the Labor Department surveyed 60,000 households. So my population is going to be all the households. My sample will be 60,000 households. My raw data will be their responses. My sample statistic will be the information we gleaned from the sample, and the population parameter is what we could glean about the population itself. So my population is that group that the Labor Department wants to work about, or in other words, the people who make up the civilian labor force. So all the people in the civilian labor force is the population. The sample is just the 60,000 we surveyed that were in the labor force. The raw data was what we collected, what we asked those 60,000 people. The sample statistic would be a way of summarizing it, and in this case it was the percentage who were actively seeking employment. So my sample statistic would be the percentage who are seeking employment, while my sample itself was the 60,000 of the population, which was all the people. The population parameter, they didn't give me any, but once the relevant population parameter would be the actual unemployment rate, which we don't know, but that's what we're trying to estimate using using the sample. So that leads to, how do those sample statistics relate to the population parameter? How can I use that statistic to make an inference about the population? This one they just kind of throw in this time out to think, sorry. So suppose Nielsen concludes that 30% watched the Super Bowl. How many does that represent? So if we wanted to figure that out, we'd just do 30% of 300 million and get an estimate that way. But keep an eye on the newspaper for stuff like that will come along. As you start taking statistics classes, you start noticing these things more and more. All right, so let's move on. Here we talked about how a poll was conducted and discusses this idea of what's called margin of error. Figure 1.1 is in your book. So the poll here was conducted by CBS News poll, was based on telephone interviews, and we'll talk about sampling methods in another section. They asked 1,315 adults throughout the state. 1,026 of those said they were registered to vote, and the interview could have been either in English or Spanish. So in theory, 19 out of the 20 of the results were based on the samples will differ by no more than 3 percentage points. That's what's called the margin of error, how much off you're willing to be. So when we look at this bottom, it says the margin of error in a survey or opinion poll usually describes a range. So you're going to be finding a range of value shortly. This is our first little math thing. With 95% confidence to contain the population parameter. So we're going to use a sample to figure out, well, we think the true population parameter or characteristics is within these amounts. So here it says the excerpt from the New York Times explains a margin of error of 3%. So that means it could be 3% above or 3% below the number they came out with. The 95% confidence means I'm 95% confident that if I do a whole number of samples of the same size, 95% of the time I will trap the true population parameter within my 3 percentage points here. So my definition for margin of error in a statistical study describes the range of values or a confidence interval likely to contain that population parameter. So we find that confidence interval by adding and subtracting the margin of error from the sample statistic. So to find your lower value for your confidence interval, you take whatever the sample statistic is, like the mean, and I would subtract the margin of error, which they will give me. To find the upper boundary, I'll take that same sample statistic, say the mean, and add the margin of error. This will now give me a range of values that I'm saying that the population parameter lies in. Because we just have a sample, we don't know for sure, but we can use our sample plus a margin of error to say we're this percent confident that the true population parameter is between the low boundary and the high boundary. So if it tells me I have a 95% confidence interval, that means 95% of my samples, which do have to be of the same size used in the study, would actually contain the correct population parameter. And conversely, 5% of those samples would not. So that's what a 95% confidence interval says. If I take samples of the same size, I'm going to get my population parameter 95% of the time. 5% will be a miss. So if I want to find that actual range here, we got the Pew Research Center for people interviewed 1546 adult Americans. All right, that'll be your sample about their attitudes towards the future. When asked if they thought humans would land on Mars, 76% of that sample said yes, or definite, probably yes. So the margin of error was 3%. So describe the population. All right, that's going to be adult Americans. The sample was the 1546 of those adult Americans, and explain the meaning of the sample statistic 76%. That means 76% of the 1546 said yes. So what can we conclude about the percentage of the population? All right, as soon as I switch to population, I'm going to take that sample statistic and add and subtract my margin of error to figure that out. So what I'll do is take that 76% from the sample and subtract 3% and then add 3%, which tells me with 95% confidence, I can say that the true population parameter for the people in the population that believe this is true is going to be between 73 and 79%. That's going to be my range of values. All right, same idea on cloning humans. Here they asked if they thought they'd be cloned within the next 50 years. 51% said yes. We have 3 percentage points. Can we be confident that a majority of adult Americans, and again, they're talking about the population now, can we be confident that they will be cloned? Well, let's do our arithmetic. We've got a margin of error of 3. So if I subtract 3 from my 51%, that takes me down to 48%. And then up to 54% by adding and subtracting 3 from my 51. Well, that 48% is less than 50%, so we cannot be confident that the majority will think humans will be cloned. So always do your arithmetic first. Take the sample statistic and add and subtract that margin of error before you make your conclusion. All right, so again, they're telling you, look for an opinion poll. And do make sure they give a margin of error and then interpret what it means. This class is about statistical reasoning for everyday life. So to get you to start thinking about the things you see in newspapers and on the news and go, wait a minute, that doesn't make sense, or, oh, that makes a lot of sense. All right, so putting it all together, how do we do a statistical study? Basic steps. First, state the goal very precisely. The more precise you are, the better you will get your results. Choose a sample from the population. Now we're going to be talking about this next section about what's appropriate. You can't just go grab a couple people you know and ask them. That's called convenience. You have to have a proper sampling technique. Third, go out and collect that raw data from your sample and summarize the data. Then use the sample statistics to make an inference, like what we just did about finding our confidence interval. And then draw our conclusions. What did we learn, and did we achieve our goal or not? Sometimes you do, sometimes you don't. And we'll talk about all that this semester. So this is a nice little graphic. You start with that goal you want, which then identifies your population. So remember, your population can be as varied as the weight of potatoes at McDonald's to children ill with leukemia. So very specifically state the population. Then go draw a sample from just that population, collect your data and summarize it. That'll give you your statistics. Then you can make some inferences about the population, all of the items in the population, and then you can draw your conclusions and then see if what you have is reasonable to make some what are called data-driven decisions. Very important to gather information before you make decisions that could cost people lives or many dollars. Okay, so here if we identify our steps for the Pew Research Center, the steps were as follows. They set their goal about specific attitudes of Americans towards the future. They chose their sample size of their adult Americans. They collected that raw data by going out and asking people. Then they used techniques of statistical science to infer something about the population characteristic. And last, they make sure the study was conducted properly in interpreting the estimates, and so they could draw overall conclusions. And again, we'll talk a lot about these individual steps in sections to come. So again, decisions, the purpose to me, the words are data-driven decisions. Statistics has many uses, but perhaps its most important is to help us to make good decisions about issues that involve uncertainty. Now again, in and of itself, statistics are uncertain. The best we can do is try to get a good sample using a good method and make good inferences. If we have a bad sample, you never know, or a biased sample. These are things we're going to talk about in the next few sections. All right, so what I'd like to do is take some examples from the textbook. So if you can get your textbook out, and these are starting on page 8 and then going forward, but sometimes it helps to go through some that are not already all written out on the PowerPoint. All right, so let me get out my book for page 8. And I think you can pause this by just clicking on it, and that'll pause it until you're ready, and then click it again. Just click on the slide. That worked for me, so I hope that works for you. All right, on question number 6 on page 8, the directions say, does this make sense? Decide whether the statement makes sense or not. So for numbers 6 and 8, we'll be following those instructions. We're not going to do number 7. So number 6, let's see. Does it make sense? Explain why or why not. So a poor poll. A poll was conducted 2 weeks before the election found that Smith would get 70% of the vote with a margin of error of 3%, but he ended up losing the election anyway. Does this make sense? Yes, it definitely does. In fact, historically, we've seen this happen. Just because your sample says they do doesn't mean they will. It could have been a bad sample. They might have not asked a wide enough variety of people. You'd have to know a little bit more to know why that might have gone wrong. But it does make sense that it could happen. Number 8, beating Nielsen. A new startup company intends to compete with Nielsen by providing data with a larger margin of error, but for the same price. Well, from what we just learned about a margin of error, that does not make sense, because that means you're less confident of your results. Margin of error, the smaller the better. So if you're charging the same price for an inferior product, not a good idea. That does not make sense. All right, let's skip up to numbers 11 and 12, and you'll notice if you have your textbook in front of you, this has a different set of instructions. We're supposed to describe the sample, the population, the sample statistic, and the population parameter. So for the smoking poll, a little trick I do to get the population is I just find the sample and I cross out the number. That'll always give me the population because they're the ones you're asking. So I can see my sample is 1,018 adults in the United States. Therefore, my population would just be all adults in the United States. You can just replace that number with the word all. So population, all adults in the United States. Sample is the 10,018 adults in the United States in the survey. They told me it was found that 22% smoked, so that refers to the sample. So that is my sample statistic. They did not give me anything about the population, so I don't have any population parameter given. If I had a margin of error, I might be able to infer something, but as is, I have no population parameter. I just have a sample statistic of 22% from the sample. Number 12, birth weights, same idea. So I know my sample is 186 selected babies. So my population would be babies. Doesn't say a country or anything, so we'll just say babies. They wanted to know the average mean of their birth weights. So my raw data would have been all of their birth weights, but the sample statistic that comes from this says the mean is 3103 grams. And again, I don't have a population parameter given because they didn't give me a margin of error so I could even figure it out. So sample, 186 babies, population, all babies, sample statistic, mean of 3,103. Okay, over to wash up. This one, the directions say give the range of values for the confidence interval. All right, so we know in the restroom only 85% wash their hands. Make sure about the other 15%, which is why I always open the door of the bathroom with a paper towel or bump it open. Let's see, but back to me, or off of me. All right, so 85% wash their hands. So I would add 1% to get the higher range, and I would subtract 1% to get my lower range. So, hence, your confidence interval would be 85 minus 1 is 84, 85 plus 1, 86. So you could say that there was a range of 84 to 86% of the population that washed their hands. Right. That would be about the population, the confidence interval. All right, then let's interpret a real study. All right, this time I kept the directions with it because we had several. All right, so we're supposed to state what we think the goal of the study was and identify a possible population and population parameter of interest. Describe the sample raw data, sample statistic, and then based on the sample statistic and the margin of error, come up with a range of values called a confidence interval likely to contain that population parameter. All right, so my problem here, 23, we're talking about the death penalty. So a Gallup poll asked 511 randomly selected adults if they favor the death penalty for a person convicted of murder. 64% say yes. Margin of error 4%. So let's start with the sample. I use it to get my population. And it seems that the goal of the study was to find out if adults favor the death penalty for a person convicted of murder. So my population, though, will be all adults. My sample would be 511 randomly selected adults. My raw data would be their response to, did they favor the death penalty, yes or no? My sample statistic is they said 64% said yes. So my sample is the 511 responses. My raw data would be 64%, well, how many said yes, but then when I put that into my statistic, it's 64% said yes. I could also infer, well, no, I can't even go there. I don't know if they had some undecided or some maybe, so we have to stick with yes. Based on the sample statistic, what the range of value would be 64% plus 4 and 64% minus 4. So that would be 60 to 68%. So we could say the population parameter of those people who favor death penalty for a person convicted of murder would be between 60 and 68%. I'm confident to margin of error is 4%. They didn't give me an actual confidence interval, I want to be careful of overstating this. So the population parameter between 60 and 68% would be the confidence interval there. Okay, that should be all my examples. So you should fill out those section notes. Hopefully you were filling them in as we went. Anything you're not sure about, you can go read the textbook. It's all in there as well, and read those examples and read for understanding. These vocabulary are very important here. And then you should be ready to go to my stat lab and do homework for section 1.1.